So, good afternoon, everyone, and welcome back to our weekly guest lecture series here on Zoom. I'm so happy to have you back. Today, speaking of a return visit, we have Graham Kelly back to talk about another really interesting field experience from field work, which I think will be really fascinating. Graham has been a volunteer here for just a short while, but already in that time has done quite a few tasks, including biodiversity and conservation explainer training, some paleo prep work, I understand, discovery room work, and I think also human origins lab. Is that correct?
I'm moving into that area.
So rapidly expanding into other volunteer areas as well. So I hope you all will enjoy the talk. And Graham, I'm going to turn the session over to you now.
Okay, perfect. I am just gonna set up my screen share so everyone can get a good look at what I've been working on. But just to start off, my name is Graham Kelly, and let me set this up for everybody. My name is Graham Kelly, and I'm gonna be really presenting on. Oh, all right, let's hope that it works. Russell, could you confirm that this is visible to everybody?
Looks good.
Okay, perfect. So I'm going to be presenting on fish abundance, diversity, morphology, and diet in Kampong Klang Commune, Tonle Sap Lake, Cambodia. And that may sound like a mouthful. You guys may not know where that is, or probably don't, uh, or why I was ever there. But this is some research that I conducted while in my senior year of college, studying abroad in Cambodia. And I'm going to get into what abundance, diversity, the Tonle Sap, what Cambodia even is, a little bit later. But this is some research I did my senior year, and I'm really excited to present it to everybody. So first off, I'm going to teach you guys a little bit about the Tonle Sap. The Tonle Sap Lake is like a massive lake that is in the center of the country, and you can kind of see from this picture right to your right a big weird change that happens there. The dark blue is what that lake looks like for the dry season. And that's when I was there. I was there for the dry season for a semester, and that's just what it looks like for most of the dry season. Pretty small, but the largest lake in Cambodia. And you may wonder though, what is that light blue color you see there? What is happening there? What's that change? That's not what the lake was like 100 years ago or what it gonna be in 1,000 years with global warming. That is not sea level rise. That is what happens every single year in Cambodia. The Mekong River feeds into the Tonle Sap River that then feeds into the Tonle Sap every year and causes a massive change seen nowhere else on the planet. It's so insane of a change that the Tonle Sap Lake or Tonle Sap River that feeds the lake gets so much pressure of water from the Mekong that it flows upstream. That is such a rare thing to see in the world, and it causes the lake to multiply by 5 in its area and 6 in volume. Can you imagine a lake, any lake we have in the US, changing by that much every single year? What it would do to the people around there and the way they live? Well, that lake and the boom it has provides a lot of jobs and food to the people of Cambodia. It's the heart of the country and even supports upwards of 70% of those the people who live there, protein intake. They need this lake to survive. They rely on it, and so much so that, you know, that increase in area and volume every year from the lake during this wet season, it doesn't mean that people live far, far away from the lake and avoid having their house, you know, washed away. Instead, that increase doesn't stop them. That whole light blue area you're seeing on the right, that whole area is fully populated. There's people there year round, and they live in these stilted houses that are really high up in the air. They also live in floating villages that are entirely and year round away from the shore, far off in the middle of the lake, and they've really adapted to living in a place like this that fluctuates so greatly. This place is home to hundreds of fish species, with that number also fluctuating depending on the season. Endangered bird nesting sites, endemic reptiles, endemic meaning they are found here uh, and unique to this area. But also there's floating Khmer and Vietnamese villages. They're really cool. We got to actually explore and see some of these villages, stay in some of them. A lot of them are on top of big oil drums that are filled with air, and just they built a little house on top of it. It's beautiful. Uh, and it's a lot of Khmer and Vietnamese people there. Vietnamese people who fled from Vietnam during the war, and to hide, they had to go in the middle of the lake where no one could find them. And it's being such a huge lake, they can have a whole village in the middle of the lake and no one's wiser. But it's a really incredible place, and that's why I thought it was a perfect place to do a presentation on and do research on. So let me give a little context to what's happening there now. This lake supports the entire country essentially. And in the modern age, just like so many other places in the world, that natural habitat, the ecosystem is really suffering from humans. We're causing a lot of habitat degradation. And by that, I want to get a little specific. It's not just the polluting and humans living there and encroaching into that environment. The whole floodplain being the area that becomes flooded during the wet season. A huge area of the country, it's filled with flooded forests that are adapted to survive that flooding. Uh, but people need wood to build their houses or build whatever they want. And that kind of causes a lot of pressure for them to go chopping down these flooded forests. So those flooded forests are disappearing. But at the same time, the roots of those trees in the flooded forest protect a lot of young juvenile fish and help them live and survive and thrive. So that's a big impact on the ecosystem when you take away the nursery for the young fish. Climate change also affects the water current, and so do dams, because this boom in lake size and volume is attributed to the Mekong River and all the water coming down it. So if you put dams there and have climate change, that can really have a big impact. I'm going to end with two more points of pollution. I'm going to skip over overfishing for a second, but with pollution, there's a lot of people living on that lake. And from one individual fisherman that we talked to in one of these floating villages, she said something really interesting where growing up, they would wash their clothes in the water. They'd drink from the water. It's fresh water. But nowadays, they don't even wash their clothes in that water. They say that if you drink it, it affects your brain. They say that the fish that live in that water now, after all this pollution, they are different. They're weird. They kind of just hover around. They don't have really a sense of the stimuli they're getting from their environment, almost like they have some neurotoxin in them. So something's wrong with the water almost. It's been polluted. Then I want to end with overfishing. And this is a real big thing I'm going to focus on because it's a real big issue. With so many fishers being desperate and poor and really on the edge of poverty, they need to turn to alternative fishing solutions or fishing methods to just make ends meet. And that has really caused a big problem there. That has caused a lot of people to turn to what's known as electric fishing or electroshock fishing. It's pretty easy. If anyone likes fishing, I'm a big fan of fishing. Uh, Instead of putting a rod in or a net in the water and trying to see what you can get, you can just put a car battery in the back of your boat and put a wire in the water and drag it around. And you don't even have to go down to get the fish. You don't even have to struggle to reel it in or pull up a heavy net. It shocks everything. It indiscriminately kills every single fish that it comes by, and they float to the surface, and the fishermen are able to just pick it up. You also have to consider that that's super effective and takes so little effort that it's overexploited. Not only that, but that overexploitation, all these fish are floating to the surface. But with normal fishing, you catch a bunch, and the fish you don't want or you don't eat or that are too small, you throw back, so that someday the smaller ones will get big and you can eat them then. But with this, you're picking out from the water's surface all these dead fish. You're picking the ones you want, but the ones you don't want, you don't get to throw back. They're already just dead. So it really just takes out everything in the environment. And it's caused a big change. So what I wanted to do in the study was just see what are ways, or in what ways are fish populations changing in these recent years. And I focused on really four main things. Abundance, which for those who don't know, the abundance is a measurement of the exact number of individual fish in that lake. So it's not the amount of species or the amount of families of fish, it is the exact number of how many fish you're catching. Diversity, we focused on family and species diversity. I'll get into those meanings a little bit later, but just, how many different types of fish were in that lake. Then there was morphology, and we broke that up into some categories you'll see soon of, body shape, tail shape, mouth position, and then lastly, diet. What are these fish that are surviving, that are, persevering in this lake? What do they eat? What is the advantageous diet to be able to survive here? So the way I did this little study is we went to Chemkar Yun village in Kampong Klang commune within Cambodia. This is a small little village that periodically gets flooded in the wet season. That is on the kind of center north point of the Tonle Sap. And you can see here it's really close to the water during the dry season, so it gets very flooded during the wet. To the right and left in the image above, you're going to see stilted houses. And these aren't, few feet in the air. They're high. It's the top of the tree that you're getting the whole tree to make those stilts. It's a big endeavor. That really shows the commitment of these people and really how they've adapted to the lifestyle here and kind of made it part of their culture. So what we did is for 6 days, we went to a individual fisherman's house, and every single morning, bright and early, we would go there and she would go to her fishing traps, which are two stagnant lop traps that she had outside of a flooded forest in more open water. And she went to these traps, collected every single fish in that trap. She didn't throw anyone's like she didn't want. She didn't throw them out. She got every single thing she caught in this trap and she brought it to us. And basically, we would one by one go through every single fish and sort them by species, weight, and length. For species, we sorted them by their Khmer name. And Khmer is the predominant language of Cambodia from the Khmer people. And we then would have to, after the sorting and weighing and length measurement, go back to our center where we'd stay, where my abroad program was centered at. Uh, and there is where we would translate their Khmer name to a more Western scientific title and use that information to kind of see what uh, tail shape they had and their morphology, where their mouth was, what body shape they had. Uh, I also want to mention, though, that this study was conducted in 2023. In 2019 and 2014, uh, other students from my program did similar, if not exactly the same, studies measuring these same factors that instead of my study being done in the dry season, they were done during the wet season. And you're going to see as I kind of go through my study, me compare my 2023 study to the 2019 and the 2014 study. And I just want to say it now, and I'm going to remind later that these were done at different times of year. So they're not directly comparable, but all the same, they are still valuable sources of information for what we're trying to find here. This is showing off a little average day. We would collect a fish and lay it out on a piece of paper with its Khmer name, and then just stack up every single fish like it, sort them by species, and smell a lot by the end of it. I did get to eat a lot of the fish, though. The fisherman was very kind, and his wife would fry them up for us as a little treat. So it was 6 days of a lot of work, but it was very much worth it. All right. Now I'm going to tell you guys a little bit about the morphology. So the morphology basically means like, what its different physical characteristics are. There is its mouth position, its body shape, and its tail shape. I'll start with mouth position. Uh, it predominantly had about 50% of all the fish we caught were terminal mouth position. What terminal means is you can see in this picture a little bit, it means its mouth is in the front of its head instead of like a catfish that has it at the bottom of its head, or some other species that may have it at the top of its head that faces upwards. This means a terminal mouth position is facing forward, not down, not up, facing forward, with the second most popular mouth type being inferior, which faces downward, like a catfish. Secondly, there was body shape. And you can see it is a pretty clear winner right here. Fusiforms are the most common by a lot body type that we found, with 80% of every fish we caught having the same body shape. The image below it shows that off a little bit. Uh, it's kind of the classic fish look when you imagine a fish. It's not a flounder that's flat, not a barracuda that's more tubular and long. It's a very, you know, thin, but has a little, shape to it, and just a classic fish shape. And I'm going to go into these a little more in a second. But lastly, there was the tail shape type, with almost 90% of them all having a forked tail. Extremely common. And once again, it's a characteristic that you think of when you think of fish. That forked tail is a classic thing among so many different fish species. And put those all together and get the fish on the bottom here. Forward-facing mouth, that more fusiform body shape, and a forked tail. What do these characteristics even mean? What does this actually tell us about what fish are living in the lake? And by what fish are living in the lake, it's what traits are advantageous to survive so much overfishing and pollution and human encroachment. Their mouth, for instance, being forward facing, is really good for a generalist diet. And for generalist, I mean they don't target one food source. They don't just eat algae or other fish or insects or one thing in particular. Uh, if they had a more downward facing nose, which a lot of them did, it would mean they eat like, they're bottom feeders. They eat small animals or algae and plant life that's on the bottom. And if they had a top facing mouth, it means they prey on animals or insects on the surface. But a forward facing mouth means they're more generalist. They just kind of eat what they can get. And that fusiform body shape tells us a lot. That body is very kind of thin and really built for endurance. It allows that fish to swim for really long distances without getting tired. Lastly, the forked tail that we see there kind of backs up that endurance point of it's good for long distance traveling. You pair these things together, put together all these different characteristics that were so common in these fish. You know, it can travel long distances without getting tired and enduring it and eat whatever it can get. What does that tell us about, the characteristics needed to survive nowadays in the Tonle Sap? Well, basically tells us that the fish there are moving long distances in search of basically any food they can get. They're really combing every inch of this lake to just see what they can get. And it almost tells us like, are there not many resources available? Is it hard for them to survive here? No, they don't have characteristics that are good for ambushing prey. They don't eat other fish necessarily. They are moving long distances. They're not just staying in one area. Like these are characteristics of a fish that's struggling to make ends meet. To continue on these points, the diet of these fish, like the advantageous food source for them, I'm going to compare between 2014, 2019, and 2023 and just see what that change says. Like, I want everyone to kind of think about this. And well, considering these studies were done at different times of year, I want everyone to look at what I'm about to say and show uh, and really think about what this means for a fish, what this means about the best way to survive in the Tonle Sap. Herbivorous fish, none. Piscivore fish, piscivore are fish that eat other fish or predatory species that are usually large and uh, there's very few of them given that they're predators. There's not as many of them as there are other species maybe, but they eat other fish. And you see there's basically no fish that eat other fish, no predators. A ecosystem needs predators. It needs someone controlling the prey species, but there's no predators here. As for insectivores, there was almost 50% insectivores in 2014. There was a slight decline in 2019, but then it just dropped. What does that tell us? It basically just tells us, a lot of things. One explanation for it could be I did my study in the dry season, those two were in the wet season. High water levels mean that a lot of bugs can lay their larvae in the water. And when it's low water, that means that they're not laying eggs, they're not reproducing as much. It could make sense that, there's not a lot of insectivores because there's not a lot of insects. But such a steep decline like that, that almost hints to us that maybe there's not enough insects. Even at its best, there's not enough to really support a species that specifically and kind of exclusively feeds on them. To continue, algivores, those are fish that eat algae, uh, have been consistently declining. In the year I did my study of 2023, once again, it's the dry season. We expect that to influence what diets these fish are having. But between 2014 and 2019, you similarly see a decline. So, once again, suggesting there's not enough algae for a species to really be exclusively eating algae. Last off, you're going to see omnivores. And I think I would assume everyone's eyes would have been drawn to omnivores for this entire presentation or for this entire slide, just because it's so obviously a massive uptick. There is 73.3% omnivores, which means that 73% of the fish that we got were exclusive or entirely eating a variety of food sources. They weren't exclusive to one niche. They weren't only eating insects or this or that. An omnivorous fish, it eats a variety of things. It can eat algae, insects, fish, plant life. As humans, we're omnivores. We eat meat, we eat plants, we can eat insects, or that's something we did when we were in Cambodia. That was a popular food, and we gave insects a try. But what does this tell us? In 2014 to 2019, when the same exact conditions and it being the wet season, omnivores increased by a good amount. And then even in our year, it skyrocketed. Once again, this could be because the water level was lower, but it seems more than that. It seems like this tells us something. It seems like it tells us that there's no one food source that's stable or plentiful enough. That the only way a fish can survive is if it eats a little bit of everything, that it eats whatever it can get. And if it focuses on only one food source, it's not going to be stable enough to really support a population. To take this further, what were our results when it came to diversity and abundance of fish? With my study, in those 6 days, we found 4,962 fish, which means that in the course of those 6 days, I personally held in my hands, measured, weighed, and sorted almost 5,000 fish. I got told I didn't smell good, and it was a lot of work, but it was really enjoyable just getting to look at each individual one and having that more personal connection with the specimen I was working with. We also recorded about 49 species and 25 families. I mentioned this before. A species is a really specific title. For those who don't know, like we as a species are Homo sapiens. That is us, a Neanderthal or chimpanzee, even though they're related, are not in our category of species, being Homo sapien. Family is similarly a way to categorize and define different types of animals, but it's more broad. Going along with that previous example, while our species is Homo sapien, our family is Hominidae, which means great apes, which includes, gorillas, chimps, stuff like that. So species, I'm just trying to say, is a very specific definition, whereas family is a little bit more broad. And when it comes to the amount of families that we recorded, I want everyone to look to the left and see that this graph is almost dominated by really two different families. We have Cyprinidae, which is 46%, and 25% of that is Bagridae. You guys don't have to know what that means at all. I'm going to just tell you Cyprinidae, it's a lot of minnow species, or what you'd call a minnow, because that's not really an official title to say something's a minnow, but Cyprinidae is a lot of small minnows, and it takes up 46%. That's a really huge amount. Secondly, Bagridae is kind of like these catfish-like small barbed bottom feeders. And just these two families alone took up so much space in the lake. It seems like there's really two families that dominate this entire area. Uh, to have almost 50% is incredible. To expand on that a little bit, I said that 46% were in Cyprinidae. There's a lot of different species in Cyprinidae, but one species in Cyprinidae was so plentiful, you're going to see it on the left here, that it accounted for 20% of all the fish we caught. I'm not saying that family accounted for 20%. I'm saying this fish alone was 20% of that essentially 5,000 fish I held. To the right, you're going to see Bagridae, or a member of that family, and this fish took up 17% of all the fish that we got. This one species was 17% of every single fish that we caught in that 6 day span. I have here, could be a little fun if you want to try to, in your head or out loud, wherever you guys are listening from, try to read through this a little bit. And you're going to see on the top the more Western scientific name, and below that is the Cambodian or Khmer name, the dominant language in Cambodia. And I'm not going to act like this is some, prank or test where once you guys answer, I'm going to tell you, oh no, it's actually pronounced like this, haha. I can barely pronounce them either, but tre means fish, which is usually the word that precedes the specific name of the species. So it's tre knoong veng and tre cantus che. Uh, but you really see that this is all to pretty much show that the lake is dominated by a very select and small group of species. It's not a little bit of everything. It's a lot of bit of just these guys. And that tells us a lot. This is a, fun little graphic I tried to make that conveys a certain point. So for the Cyprinidae family, the ones that took up so much, or 20%, they live in the middle of the water column, which is a position that keeps you very exposed. You're not covered by plant matter or mud at the bottom. You're just out in the open. And for such a small animal like this or small fish, it's dangerous. That's why they travel in schools. They're essentially minnows. But usually their population is kept in check by these large predatory fish, which I showed on the right. Since these minnows are so exposed and small in the middle of the water column, their population is checked by those large predators. But for their population now to be so huge, it almost seems to be telling us that there's no more large predators that are taking them out. They're able to be like plentiful out in the open of the water column being, the dividing lines of the top of the surface, the bottom, the middle layer of the water. And these guys live just like right in the center, which is so exposed. But being so exposed, they're reproducing like crazy, unchecked by any predator. So, knowing that there's so many of this fish tells us that maybe there's not as many predators anymore. And then on the left, you're going to see two little lightning arrows. That is showing that electroshock fishing has had an impact on basically the species able to survive. Electroshock fishing kills everything. It doesn't determine which species like you want to catch or only hit certain ones. It kills everything that's near it. And when you drop a line in the water, you're going to really massacre everything. And for the Bagridae species I mentioned, which are kind of featured below that dotted line, they are low enough down and kind of in the muck where they're almost safe from that electricity. And they're able to multiply and able to really dominate as all the other fish species have kind of been wiped out. So there's now a lot more resources. They're not enough to support them targeting one niche or one resource in particular, but without a predator, the Cyprinidae are able to thrive and reproduce unchecked. And with a real selective pressure for low down bottom feeding species, the Bagridae family is really able to thrive and survive all this turmoil. So this is kind of what we're working with now. We have a lot of these fish in the middle of the water column and a lot on the bottom, but it's not a lot of different species. It's a lot of just one or two different species taking up that space. And, there's no predator. There's nothing keeping them in check. And having no predator, like, it doesn't mean a good thing necessarily. It's not just, oh, there's more fish reproducing without a predator. Isn't that good? There's more fish. It's more complicated than that. Diversity is the basic amount of species or families or whatever you're measuring when it comes to these fish catches. Over the years, we compared 2014, 2019, and 2023 species and family diversity. Once again, a reminder, my study was done during the dry season, so that could account for a lot of the change between 2019 and 2023. But when it comes to species, the real specific category, over the years it went from 60 to 59 to 49, or sorry, 53 to 49. And that's a solid drop in the amount of species. Families, though, increased by a huge amount. The broad category went up by so much. That's something you wouldn't really expect. That doesn't make much sense of why the really broad categories went up when the specific ones went down. So what causes? Well, I have a personal theory. There's not a ever clear answer. Biology is made up of theories, and this is what I want to show as my explanation. And I'm using an example of there was a family of fish, and within that family there was five different species of fish, and each one was adjusted to a certain niche. Species one ate insects, two ate algae, three ate other fish, four ate different plant matter, and five was an omnivore, what I mentioned before, the really successful species or successful diet to have for the fish that are still living in the lake now that haven't been hunted out. Uh, and all these different fish focus on one specific niche, which is great for them and allows them all to coexist together. But when fishermen and pollution and just human encroachment are really making those specific categories not stable, like they're wiping out the different other fish species that piscivores can eat. They're dumping chemicals that kill the algae or make it boom too quickly, and they're killing plant matter. It really makes it hard to focus on one specific food type. So, what does that do? That means that the family that once had five different species in it can now only really persist with only the fifth species still remaining. That fifth species, the one that's a generalist, the one that's an omnivore. There's less fish, so piscivores can't survive. They have not enough food to eat. But there's still some fish. There's still some plants, some bacteria, some algae, some mosquitoes or different insects. And the fifth species is able to eat it all. So it survives. And that family goes from a family, one family with a bunch of members, to one family with only one species in it. So we understand now why species would go down, but why would family go up? Well, another example, we have family A that now only has one species. Family B only has one species. Family C, only one species. Those all being omnivorous species. Well, all right, all the surviving fish are omnivores. It's one species, let's say, to one family. Like that should mean species decline, but doesn't say that family would have gone up. But we have to remember it's connected to the Mekong. This is a huge river system, and with the loss of so many different species, it creates kind of a gap or a niche that is untaken advantage of. So many species once existed there, and a new species can come in if it's omnivorous and really find an environment an environment that's ideal for itself, which means that a new family is coming in, and that new family only has one species in it, the omnivorous one, but we're seeing an increase in families with an overall decrease in species because, a new species is coming in, but, that doesn't affect much the fact that each one of those families was so diverse before. Uh, you don't have to really retain all this. It's not as important, but just something to consider. It's something I found interesting. Abundance, basically the exact number of individual fish. 2014, we had 2,000 a day. And in 2019, it went to 467. Like that is a massive decrease that we're seeing in only 5 years. If that trend kept up, we would have no fish in the lake anymore. And to see that in those few years, you'd wonder, wow, what is it going to be in 2023? You'd expect at that rate, it's going to be still declining. It's going to be much lower than it was in 2019, let alone 2014. So the consistent decline of abundance should tell you we're going to get less fish. But also that we're doing this study during the dry season where abundance is generally a lot lower. There's less water, there's less food. So for multiple reasons, we should expect 2023 dry season to have barely any fish. But then how come did it have two times the amount of 2019 that was in the wet season? That seems to not make much sense. Like, why would it increase by so much, almost double? Could it be that there's a difference in the time of year? My study was done in the dry season, so that doesn't really make sense. You would expect it to go down, or you would expect there to be less fish because it's the dry season. Like, it's not a time where they're reproducing heavily or coming in from the Mekong. So that doesn't make sense. Could it be that there's less fishermen? Well, that's not really a possibility. You guys have to remember that Cambodia is a country where there's a lack of certain opportunities. If you're a fisherman and there's not enough fish to support yourself, you can't just change jobs. You have to still be fishing. If you don't catch a fish today, you don't just get to, give up and do something else. You have to catch a fish tomorrow to make up for it. So those fishers are still there. I'm going to end with, could it be an illegal fishing crackdown? I'll give you a little sneak peek. That's what the government is saying that it is. The government is cracking down on illegal fishing and saying that it's been successful. And yeah, illegal fishing crackdown does sound like a good idea. Electroshock fishing is terrible. Uh, but it's something that is done very organized. These electroshock fishing groups are usually Khmer, poor native Cambodian fishermen who've lost their work or lost their home because they're not catching anything. And they get, these Chinese companies who are, breaking the law, working independently, uh, who come in, basically loan out the electroshock fishing gear to these poor people who are just struggling to make ends meet and tell them, go out and get fish for me. So we crack down on them. Like the Cambodian government arrests these men, Khmer poor fishermen, but they're not getting the Chinese company that are funding it. So what could possibly be leading to such an increase in abundance? I want to say that my study found a solid increase of almost twofold in abundance at a time where it should be dropping. To take that further, another study done in 2023 found that between the prior season, from I did in 2022 to 2023, in the season of 2021 to 2022, uh, from 2021 to 2022, that's one season, and in the time between that and 2022, 2023, there was a 40% increase in abundance, which is 40% more individual fish. That's a good amount. Like that backs up what I was saying and what I found that the abundance is going up. It's real. It's a true thing. And that should be great. Like there's more fish. In 2024 to 2025 season, which is current, what's happening right now, the Prime Minister himself released on social media. I think he tweeted it or put it on Facebook. It's odd. But a twofold increase in the uh, abundance of fish. He didn't have any scientific data to back it up, only referenced accounts from individual fishermen that went unnamed. But to imagine in just like a year, it's gone up twofold. It seems all incredible. This seems like great information. Even the UN said Cambodia is like the foundation for a resilient fishery sector and has extraordinary surges in fishery or in fish stock. And this all seems amazing. It seems like I'm just telling you good news. Like, this isn't anything. What are we going to discuss at the end of this presentation? I'm only telling you good things. There's nothing to discuss because they figured it out, right? They figured out a way to save their lake. But do we want more fish? Is that good? This isn't a sarcastic, like, this is a real question I'm trying to ask. Do we want more fish? Is that good? It may seem obvious that, oh, of course we want more fish. Like, more fish the merrier. But there's something you have to consider. For those paying attention, what were those fish that we now have? What is the primary fish species that are making up this lake? The abundant fish that we're catching now, the ones that are so much more than they were last year, they're tiny and they're young. And those species of fish that are young are less fertile. So they're tiny and young and having less eggs, and they're unsellable. In Cambodia, they have a primary kind of national dish that is prahok. It is a type of fish paste fermented that is made up of a lot of small fish, and it's what Cambodians usually eat at home. But for fishermen, when they go fishing, the small fish they use for prahok, eat it themselves, and the larger fish they use for selling to make money. Uh, if you're not able to sell large fish, you only have small ones. That means all you have to sell is the prahok you intended to give your family. So you're not eating tonight if you want to pay rent. The lake also lacks any predators to keep populations in check. It lacks any one stable food resource, and a natural equilibrium just isn't there. To try to word it differently, I guess what this means is that it's like a forest that lost its wolves and deers and birds, become a city like New York. What once had so many different species is gone. And now it has so much more life, but it's almost not the life you want. It's consumed by rats and roaches, and it's different and it's unstable or unstable. That abundance from 2014 to 2019 showed a fish stock collapse, a major loss in species, or sorry, fish abundance. From 19 to 2023, we saw that there is a population boom. Sorry, population boom was supposed to be written there. Uh, there's a boom in population. The predators all died out. We saw a fish stock collapse, and then the boom of prey species who got to grow unchecked. The question then remains, what comes after this? A boom can only last so long. So I'll end with this. Is this boom in abundance good? What do you think will happen next? What does the current most common fish characteristics say about this lake? How do we fix it? I'd love to hear your guys' thoughts and discussion and any questions you guys have. This is the end of my presentation, and thank you all so much for spending the time and hearing me here. Means a lot to me, and I really appreciate it. I also want to end with one little thing. I'm dedicating this to my grandpa who passed away last week. He was 101. He was a big sciencey doctor guy and always very supportive. So I just wanted to throw that in there. But back to what I have. If you guys have any answers or any discussion, I'd love to hear it. And thank you so much.
And Graham, thank you for the talk. Really fascinating, at least on my end, completely new information and a really new perspective on some of these metrics. You would think more fish, growing populations, automatically that's a win for
Yeah.
conservation. But as you remind us, maybe not so. It depends on the abundance, the size of the fish, the reproductive capacity, and so on.
Yeah. That's the thing I also want to mention, like, you know, coming to that realization, you're like, oh, maybe abundance being higher isn't a good thing. That is something even the UN this year, like, commended Cambodia for it, not really realizing what that means. Like it's something we're not really realizing, like it's something we think of as good and we're striving towards, but it's kind of a dangerous mentality.
Understood. So I'd love to open up the floor now for questions or comments. If you do have a question, please press the raise hand button on Zoom and I can help you unmute and you can shout out your question to everyone in the meeting. If that's not working out, you can also jump into the meeting chat and I'll happily read out your question from there instead. All right, while we're waiting for any questions to come in, I wonder if you could help us out with some thoughts on any connections, whether here at the museum to our work, anything we might share with visitors in the Hall of Biodiversity, ocean life, or another connection that I'm not thinking of right now.
Yeah, I guess, we want to remember if you go to the Hall of Ocean Life or go to any exhibit in the museum, Hall of African Mammals, anything like that, would you rather have it as it is, where it has like, three of every different animal doing something cool? Or do you rather it's like, every exhibit is like 20 minnows and maybe one shark and a gorilla? Uh, the diversity that exists there and the abundance that exists there kind of go hand in hand. You can't have you can't treat them individually. Like abundance isn't good unless diversity is good. Uh, but yeah, I love any questions anyone has. Uh,
Excellent. Now, I'm just curious, do you have any plans for future field work, any research that you might do down the road?
uh, Nothing as I am hoping to. I know that they're continuing this work or like this study because it was done in 2014, 19, and 2023, and I know this upcoming season they're going to do another one, and hopefully that should be along the same lines mine was of another one in the dry season. Um, yeah, another thing to also mention is that uh, the crackdown on illegal fishing is, it isn't a simple fight. It isn't just getting the bad guys, the poachers. It isn't these people are evil, like they're just killing all these fish. These are people pushed towards making a tough choice. It's not like they're just, without emotion killing all these fish and leaving so many behind to just drift away, not even to eating or using. Uh, they have a connection to this lake. They care about these fish. Like they are killing them. And also the punishment for doing this electric fishing is at times severe enough that it causes death. So it's complicated. Oh, Kelby.
Yeah, let me unmute Kelby. Go ahead.
Yeah, can you hear me okay?
Yeah, I can hear you, Kelby. Hey.
Perfect. Well, great job, Graham. Lovely to hear you talk today. Just a question for you. If you had to go back to Cambodia and continue your research, were there any questions that you felt were unanswered or just things you'd like to explore more just due to the, of course, limited time frame you spent in that region? What continuing questions are lingering for you?
That's a good question. It's a good question about what question I have. I guess there's like I would want to get more into I guess just what the I was just really curious about the fact that there's so many uh generalists or omnivores. I want to know if there are any carnivorous fish or piscivores, fish that eat other fish, because people are still catching them. I admittedly ate a lot. Um, but just where are the refuges for them? Like, where do the last little bits of those populations survive? Uh, because, the fish we caught are the ones who are ideal to survive in this environment. So I want to know out of the predators that exist, where they are, because that kind of tells us where the ideal habitat for them is, in despite of all this overfishing. I brought up the slide again because 0.12% piscivores is nothing. Like, that is terrible. That's really bad. Uh, and it's not something that we can just if those fish disappear, like if those they're mainly something called snakeheads, like this one type of fish. If they're gone, it's not something we can bring back, in the United States, we wiped out wolf populations and now we have this many deer. And why do they give out so many, deer hunting licenses? Because if we don't keep the population of deer in check and cull them, they're gonna breed like crazy, and then they're gonna overexploit their resources, and all of them will die out. There would be too many of them that the whole population collapses. And I just want to know where we can find the last predators in the lake because I want to know, you know, is there enough of them in the lake and where are they in the lake that we can bring them back? Because the increase in these small generalist fish is a temporary thing. It will eventually come to a breaking point and collapse. And when it hits that point, not only are we not going to have any predators, but we're not going to have any prey.
Excellent. Awesome question. I see another question in the chat, although it's under my name. That must mean it's Susan who's posing it, I think. Great question, Susan. She writes, anyone or has anyone looked at the insects or the plants that would be consumed by some of these fish species? And if so, how have their populations changed?
Oh, sorry, I'm plugging in my charger. Was it insects and
Yeah, so insects, plants, or other things that would be eaten by these fish
yeah,
populations, is someone monitoring their populations in turn, the sort of
yeah.
food source for all the fish species?
That is a really good point. I can say for algivores, for algae, algae is really actually insects as well because it's insect larvae that's in the lake. There's a big threat to those the algae and the insects from a lot of pesticides. The Mekong soaks up water that it drains all the water from not only Cambodia but excuse me, like most East Asian countries. It is a huge amount of water, and you have to realize that the fact that the Tonle Sap River flows upstream, consider what that is. Water's going up. That only happens if there's an insane amount of water pressure in the Mekong. And all that water that drains from all of East Asia gets so pressurized and drips over so much land and leaches it that it's soaking up so many pesticides and it flows right into the Tonle Sap. And as for insectivores, or sorry, as for insects, that larva can't survive the pesticides. It dies. That's what pesticides do. And some fertilizer that is in the soil can cause booms in algae populations. And just like the small fish that we talked about, a boom only lasts so long until there's a population collapse. And many fishermen, like I suggested earlier, that woman who said all the fish in the lake are slow and weird now compared to growing up. That could suggest that the fertilizer is causing an algae boom, and some algae release neurotoxins, and when that neurotoxin is released, it affects them. It affects their brain and their ability to function. So algae could really be suffering or just at least, fluctuating because of human influence. As for piscivores, we know that it's just humans. The prized fish of Cambodia is the snakefish. Every part of the country wants a snakefish. Everybody in the country wants it. Piscivores, they're the main predator. We've wiped them out. We've overexploited them. As for herbivores, kind of a mix of everything. The pesticides, the algae, or sorry, the pesticides and fertilizer make it not ideal for them. And yeah, just the encroachment of humans, the cutting down of flooded forests, they just are susceptible to everything. And all those things combined are why herbivores are really, really threatened. So yeah, everything, that's the thing, everything is targeted, which is why you need a little bit of everything.
All right, I see another hand in the participants list. It is Mish. Go ahead, Mish. Um, oh no, there we go. Yes. Ask to unmute. Ready.
Hi, yes, I don't know if you can hear me. I hope you can. I was just curious, as far as like societal um, attitude in Cambodia towards the like population changes, but also the government's involvement and the Chinese private company involvement. Um,
Oh,
you
sorry.
know, as far as also Cambodia citizens being like for the most part under 18 because of Khmer Rouge, it's like I'm sure they're a lot more liberal, but also, there's a desperation there. So I guess I'm just curious, like what the citizens, attitude and actions have been.
That's a great question. Uh, for anyone who's hearing the sorry, for anyone who's hearing the talk back, it's because the person asking the question is in the room with me. But that's a really good question. Uh, the social aspect of it is really interesting because, yeah, the Khmer Rouge was a genocidal massacre on the whole country and left it so that really all the a whole generation was wiped out. It's everyone there is young, and even today is the 50-year anniversary of Nixon approving the invasion of Cambodia during the Vietnam War, and it just was a really hard time for these people. And most of the country is young, very young, and in the last few years, it's gone from a society of like, the whole country was dispersed evenly. There weren't like the big cities existed, but people didn't flock to them. The young people didn't naturally just go there when they got to a certain age. But nowadays, since resources in these villages, like their fishing isn't going well, you can't survive off fishing, you can't survive off this one thing or that, you're kind of pressured or forced to then move into the big cities to support yourself. You know, your father you see every day is struggling to get by getting fish. You're not going to become a fisherman. Like you don't want that for yourself. And yeah, it's you could see it as a good thing that, they're going to the cities, they're getting degrees, they're going to school and making, you could say making something of their lives in a way, but it's not, that's a, I think, warped way to see it, or maybe biased way to see it, because the expense of what like that, the expense that comes with is that this traditional culture that's been there for so long, like these people have been here for generations, and they have been, to imagine living in a country where your family's been there for thousands of years, and every single year the lake increased by 5 times, like its area. There's such a culture tied to that aspect, and there's such your way of life is so based on that change that when you move to these big cities and you leave that lifestyle, you're leaving something that's so special and unique, and they don't necessarily want to leave that. They don't want to move to these cities. It's a beautiful life. Like there's never anything wrong with it. It's now just that they can't do it anymore. So there's a kind of a loss of culture that's happening really, really quickly, and it's a concerning thing. I'll leave with that.
Yeah, great question. And I do see we're almost out of time, but I think there's one question left, and it's from Tom, and we'd love to give Tom a chance to jump
Uh,
in. Go ahead, Tom.
oh, sorry.
Yes. Hi, Graham. Thank you for that fascinating professional presentation. I didn't know any of this. My question is, uh, have you or the school shared your research with the Cambodian government? And as a follow-up, do you know if the Cambodian government is doing its own independent research on its own?
That is a great question. I'll say two things. I was asked to share this research with community members in a presentation. So I got to, show some people, uh, these results, give them at first, what seemed like a positive hope for the future that there's an increase in abundance. And it was some of the first recorded signs of that increase. Uh, but with the Cambodian government, they know it's increasing in abundance. Kinda like I did a study on it. And I was like some of the first studied or, official research to be done on it. Uh, but the Cambodian government is also claiming the same thing. So one would say like, oh, that's great. We can both agree, but they're not doing any science behind it. They're not showing any, scientific method to their claims. It's like, I think it's dramatized kind of inflated information. The increase I do think is there of abundance, but like I've been saying, they're really, oh, increase abundance. Like it's amazing. There's so many more fish, two times the amount of fish. If you have a snakehead fish that's this big, like a huge thing, and you're trading that out for two minnows, to act like that's a good thing, it doesn't make much sense. Uh, the prime minister is up for re-election, and he said that while he was running his, this during his campaign, and it seemed like that, I just want to say maybe take it with a grain of salt that there's no, necessarily proof, and that there's a lot of political influence in this information because it is coming from a tweet from the prime minister. Uh, so yeah, and also the prime minister at the same time is, you know, hand in hand with his idea of abundance is going up, is he's trying to get people to return to their roots of prahok, like the fish paste dish, which relies on small fish. So he is kind of telling people, start having prahok all the time. And then if people will be like, okay, I'll start having prahok all the time instead of trying to get big fish. And then they're going to put their net in, see, wow, there's so many small fish. It's great for prahok. And just kind of getting them to not really notice and not really, you know, have issue or complaint with the fact that, these large fish species that they usually get a lot of money from are gone. He's trying to make people happy that they're getting scraps of what they once did by kind of at times seemingly like concealing it in a like return to older culture when every single like fish in this lake has been culturally significant. It's not just the tiny ones. If anything, it's more the larger ones. Uh, but yeah, it's just kind of there's a lot you really have to, consider the situation that is going on around the lake. It's not just the lake, it's what's going on around, what's happening outside, it's the people, it's the politics behind it. I like biology. I wish it was as simple as just, everything except the politics, but it's unfortunately a really big factor you have to take into account when you're trying to be happy about good news. Yeah.
Excellent. And I think that's a great point for us to conclude our Zoom for today. Graham, once again, thank you so much for this session.
I'm really appreciative of everyone who showed up. I see a lot of names that I think are really awesome people that I'm so glad are here, and it makes me very happy. So thank you guys all for listening.
Excellent. And so I suppose I should welcome everyone back next week. We're actually going to have two talks at slightly unusual days and times. So for Monday next week, we'll have a 3 o'clock talk, not 1 o'clock, but 3 o'clock. This will be Abby Perez and Rachel Chaffee. They will be, those are coworkers here at the museum in the education department. They will talk about their research project here on site called Talking to Strangers About Science. It was published pretty recently, and I would love for them to share some of the results of that research with all of us, since we are, in many cases, facilitators here at the museum. Then on Wednesday of next week at 1 o'clock, Ron Korsak will return for part one, the on paleontology in the Renaissance, and there'll be a part two later on in the spring. Then the following week, on Monday the 12th, we will have Tom Parker, who's going to talk a little bit about natural selection and the human diaspora. So the genetic history of our own species. So hopefully you can join us for at least one of these talks, if not several. So everyone, have a great afternoon. Thanks so much for joining us.